Ethernet frame structure, the container that carries the data through from source to destination. This is the package that's true. 7 main fields make up a standard Ethernet frame. Let's break it down layer by layer. Remember the name: Ethernet frame. Preamble SFD, destination MAC, source MAC type data and pad FCS at the back. From 64 to 1500, 18 bytes in size. Ethernet frame structure, now you've got the eyes. Every frame starts with synchronization and ends with error check. Ethernet frame structure, that's the protocol tag. Ethernet frame song, clear and true. Network plus Ethernet, mastered by you. First comes the preamble, 7 bytes of alternating ones and zeros. Helps the receiver NIC synchronize its clock. That's how it goes. Then the start frame delimiter, SFD 1 byte that says here we start. Marks the beginning of the actual frame, that's the important part. Next is the destination MAC address, 6 bytes long. Tells the switch or NIC exactly where this frame belongs. Followed by the source MAC address, another 6 bytes wide. Identifies who sent the frame, that's the sender's pride. After the MAC addresses comes the type of length field, 2 bytes that tell what protocol is writing in the yield. 0 to 1505 tells the length of the data. Above that value means it's the ether type IPv4 or IPv6 data. Then comes the data and pad section, 46 to 1500 bytes. The actual payload from the upper layers, that's what it conveys. If the data is shorter than 46 bytes, padding is added in, so the frame meets the minimum size requirement. The win. Finally, the frame check sequence, FTWS 4 bytes at the end. CRC error detection, if it fails, the frame is dropped, my friend. It calculates a checksum on all bytes from destination MAC to the pad. If the receiving device sees a mismatch, the frame is considered bad. The entire frame ranges from 64 bytes minimum to 1518 max. Anything smaller is a runt, anything larger is a giant. Those are the facts. Jumbo frames can go up to 9,000 bytes or more in data centers high. Within the normal size, that's the rule to apply. Remember the order when troubleshooting with Wireshark or a sniffer tool. Preamble and SFD help sync the MAC addresses rule. Type field tells the protocol, data carries the real payload. FCS at the end checks for errors. That's how the story is told. Broadcast frames of destination MAC all ones. Multicast frames start with 01005E. That's the specific address. Understanding frame structure helps you repack it, captures right. It turns raw data into meaningful insight. Ethernet frame structure. Preamble SFD, Des MAC, source MAC, type of length, data and pad, FCS at the back. 64 bytes minimum, 1518 max. This is the container that carries your data across the track. From synchronization to error checking at the end. Ethernet frame structure, now you understand the trend. Ethernet frame explained, clear and true. Network plus Ethernet mastery, achieved by you.